Okay, right now this is stage 14 on approximation games, Math City games, and here is the purple bet, and I want to show you how to approximate to the nearest 10th and 100th when 0 is left in its place. Now, I once said in a stage earlier that there is a rule against knocking off the zeros after the decimal point, and here we are faced with one of such rules. Generally, the zeros at the last position after the decimal point are knocked off after approximations, e.g. 36.800 is written as 36.8. However, when approximating to the nearest 10th, 100th, the zeros required to fill up the space of the specified approximations are left untouched. That's just it. For example, if I approximate 18.041 to the nearest 10th, I expect that I should have 18.000 because 4 is rounded down, and then I should have knocked off the 3 zeros here, but I won't do that because I was asked to approximate to the nearest 10th. I have to leave a 0 in the 10th place to represent my approximating to the nearest 10th, and that's the rule. So the same way, if I approximate 5.987 to the nearest 10th, I'm going to get 5.9 and 8 being rounded up to this becoming 6.0. So 6.000 is what I'll get, making it 6.0 because I have to leave 1 0 in the 10th place. And then also 27 to the nearest 10th. Quite impressive to know that 27 as a whole number is not alone. 27 as a whole number actually could be expressed as 27.000000 as much as you can represent. However, if you want to approximate 27 to the nearest 10th, revealing all the other zeros it can contain, you realize that you need to knock all of them off except the one in the 10th place, and so you got 27.0. Now, coming to the nearest 100th, the same thing you're going to do. If you were to approximate 5.0032 to the nearest 100th, you would have just done 5.00, then 32 is rounded down to be 00, and we would have just said 5, knocking off all the zeros. But no, because it's to the nearest 100th, we leave the 2 zeros that will represent to the nearest 100th, and so we got 5.00 as the appropriate answer to this question. 16.695 to the nearest 100th should become 16.700 because 5 is rounded up, and with 1 on 69 it becomes 70, so we have 16.700. So one of the zeros alone is knocked off, so you have 16.70, so you can maintain 2 digits for the sake of nearest 100. Same goes for 14 to the nearest 100. Like I explained before, a whole number such as 14 could be represented as 14.000000 as much as you can write. However, we knock off all the other zeros and we are left with just 2 of them to represent nearest 100. So if it is to the nearest 1000 and whatever it is, you just leave as much zeros to represent them. So to the nearest 1000, you should have left 3 zeros, and so it should have been 14.000, and so on and so forth. So now that is it, and we can check our further explanation page to see what's up there for us. In the further explanation page, we have, as usual, to approximate 18.041 to the nearest tenth, round off 4, the result is 18.000, which should be written as 18.0 because the 10th place must be occupied. Same goes for every other thing that has been done. Let's take one of such example on the nearest 100. In the same way, to approximate 5.0032 to the nearest 100, round off 3, the result is 5.0000, which should be written as 5.00 because the 100th place must be occupied. So that is how we go, and now we can go ahead and start the game. In the game, the first question here is approximate 6.01 to the nearest tenth. We would have 6.00 out of this, which should become 6.0 to the nearest tenth. Approximate 8.95 to the nearest tenth. If we round up 5, we would have 9.00. One of the zeros alone is going to be knocked off, so we still have a 0 left in the 10th place, so we have 9.0. To approximate 4.995 to the nearest 100, 5 will be rounded up because the 100th digit is this 9, and that makes this become 5.000. Now we should go off with just the last 0 because we need enough zeros to fill up to the 100th place, and so we got 5.00. And next question is approximate 16 to the nearest 100. 16 to the nearest 100 should just be 16.00. Enough zeros out of the infinite zeros that could be written here. Enough zeros to fill up the 100th digit place. And lastly, we have approximate 18.197 to the nearest 100. Of course, 7 should be rounded up, so we have 18.200. However, we need it to be 18.20 so there be enough digits to fill up the 100th place. And that's it. When you are done with that, you hit this button to the next level, and when you're done with that, you hit this button to the next stage, which is the beginning of the brown belt. Happy viewing, catch you in the next stage. Bye for now.